Good morning, students. My name is Mr. Dominic. In our last class, we talked about electrolysis, and we have been able to define electrolysis, define the various terms using electrolysis. We also state Faraday's first and second law. Then we did some little calculation under electrolysis. Then we also stated the application of electrolysis. Today we're going to be looking at conduction of electricity through gases, which is partially like a continuation of electrolysis, because electrolysis is the conduction of gases for electricity through liquid. But today we'll be talking about conduction of electricity through gases. We can remember that in our last class we said we can study the conduction of electricity through liquid using a voltmeter. But in today's case, we're not going to be using a voltmeter. What we use to study the passage of electricity through gases is what we call the discharge tube. The discharge This whole setup is what we refer to as the discharge tube. This whole setup on the board is what we refer to as the discharge tube. Now, this is the discharge tube. The discharge tube consists of what? Of a glass tube, then the two terminals which act as the cathode and the anode. The cathode being the negative terminal and the anode being the positive terminal. And it also have a vacuum control, a vacuum pump control. This vacuum pump control is connected to a vacuum engine, whereby air is being able to be sucked out of the container. And also it contains a power supply. This whole configuration here gives you what we call a discharge tube. Now, this discharge tube is what we use to study the flow of electricity through gases. Okay, on a normal day, we know that electricity can be transferred through air, through gases. But how can this be made to conduct electricity? How can this discharge tube be made to conduct electricity? Experiments with the discharge tube shows that gases conduct electricity under low pressure. Low pressure. And this low pressure, we're talking about the value of minus 0.01 millimeter mercury. Minus 0.01 millimeter mercury. That is the pressure under which gases will conduct electricity. Another condition under which a gas will conduct electricity again is number 2, high voltage. And this high voltage, what are we talking about? We're talking about a voltage of about 1000 volts. Voltage of about 1000 volts. So these are the two conditions under which gases will conduct electricity. These are the two conditions under which gases will conduct electricity. I'll say it again. Number 1 is what? Low pressure, and secondly is what? High voltage. And low pressure, we're talking about minus 0.01 millimeter mercury, and for the voltage, we're talking about what? 1000 voltage. These are the two conditions under which gases will conduct electricity. Under these two conditions, a gas in a discharge tube will glow. When I say glow, it will bring out light. Why does it bring out light? Because the atoms in that particular tube are being given energy. And when they are being given energy, it produces an electron. And the electron moves from where? From the cathode to the where? To the anode. Moves from the cathode to the anode. That is why another name given for the electricity, the glow, the light that comes out of the discharge tube is called the cathode ray. An example of the cathode ray is what we see in our olden days television, our box television. There's what we have at the back of the television called what? The cathode ray tube. That cathode ray tube on a normal day produces light. And it's what? It's hot. Why? Because electrons are what? Are traveling. And whenever electrons are traveling, it always gives out what? Heat. Please make note of that. Whenever electrons are traveling, it always gives out heat. Okay, next we'll be talking about the nature and properties of the cathode ray. Cathode, like I told you, another name for the electricity generated through gases is what we call the cathode ray. What are the nature and what properties do they have or exhibit? Number one, we say they consist of what? Moving, streams of fast moving negative electricity. Negative electricity called electrons. They are moving very fast, streams of fast moving electrons. They are attracted towards the what? Towards the anode. Remember, we said the anode is the what? Is the positive terminal, while the cathode is the what? Is the negative terminal. So the cathode produces the negative electron. The cathode produces the negative, so it is attracted through what? It is attracted to the positive terminal. Negative electron is attracted to where? To the positive terminal. Secondly, we said they cause glass and other materials like what? Zinc sulfide to fluorescent or glow with what? Greenish color. It causes glass to glow with what? With greenish color. Examples are our fluorescent bulbs that we see. Those fluorescent bulbs that we see, that we use in our house, those glass tube that we use, or all those bulbs that we used before as our fluorescents, they contain gases. And those gases are under what? Very low pressure. Very low pressure. That is why they give out that light they give out. That light they give out is what? Is the movement of what? Of electrons between the terminals of the tube. That is why it gives out light. Thirdly, they travel in a straight line. They travel in a straight line. They never bend, just like light. They travel also in what? In a straight line. They are deflected by electric and magnetic field. They are deflected by electric and magnetic field. Whenever they emanate from the negative terminal of the cathode. So, if you bring a positive terminal closer to the negative terminal of that cathode, cathode, yes, instead of it traveling from the negative terminal of the discharge tube to the positive terminal of the discharge tube, no, it won't travel like that. Instead, it will deflect towards the positive terminal that you brought close to the discharge tube. That is to tell you that they are deflected by what? By electricity and also magnetic field. For example, now if you bring a north pole of a magnet close to the side of that discharge tube, instead of it traveling from the cathode to the anode, it will bend towards the magnet that you brought close to the discharge tube. Another is that they ionize a gas through which they travel. They ionize a gas through which they travel. They will turn a light pedal wheel in the tube, showing they have momentum. They have momentum. Whenever you put a pedal in the tube, a pedal is like a pedal of a bicycle, a very light one in the tube that can rotate freely. If you on the discharge tube and it starts giving out electron, you see that wheel rotating. That's to tell you that those electrons has what? They have energy and they also have what? Momentum. They have energy and they also have what? Momentum. Another property is that they can affect photographic plates. They can affect photographic plates. They can produce X-ray from high density metals when they are suddenly stopped by such metals. We know that X-ray are produced when electrons are suddenly stopped by metal. Yes, when electrons are suddenly stopped by metal, it produces X-ray. So such scenario too, whereby these electrons are being stopped by metal, produces what we call X-ray. They also have high penetrating power. They also have high penetrating power. They can penetrate sheets like aluminium, foil paper, and the rest of them. They have high penetrating power also. So all these are the properties and nature of the cathode ray tube. I'll say it again. All these are the what? The properties and the nature of the cathode ray tube. Excuse me. For your assignments, this is what you will do for me. What are cathode rays? You define what cathode rays are. What are cathode rays? Secondly, list 5 properties of cathode rays. List 5 properties of cathode rays. Like I normally tell you, drop your answer on the comment box. Drop your answer on the comment box. Or alternatively, you can reach me on my phone number, which is what? 08064818759. Yes, I attend to WhatsApp messages. So you can send your answer to this number and I will attend and I will reply you back. Okay? Do take care of yourself and have a nice day.